So now let's apply the rules for aromatic, anti-aromatic, and non-aromatic and find out if the following molecules, we can classify them as any of those. So here we have cyclopentadienyl cation. What it has, we have a fully conjugated system. This cation is similar to the allylic cation. We know that it's conjugated, and we can do resonance here. So we can do electron delocalization, and in the resonance structure, you will have a double bond here, and that's the charge. So that's similar, and that is sp2 hybridized. So it is completely, fully conjugated, so that system of p orbitals overlapping, it is cyclic, it is planar. But now, how many pi electrons do we have? So here I have 2, and 2 is 4 pi electrons. So that doesn't meet Higger rule, because n equals 0, you will have 2 electrons. So let's do that. If n equals 0, that's for 2 pi electrons. If n equals 1, it's 6 pi electrons. And n needs to be an integer, so that doesn't meet that. If n equals 2, that will be then 10 pi electrons. So notice how this go. So we're going to be applying that. So aromatic compounds will have that. N needs to be an integer. So let's do one more molecule on that. And let's say that I have now pyrrole. Pyrrole is this. In pyrrole, we need to analyze first if this is conjugated. It is cyclic. Will it be planar? Well, now, we have a nitrogen atom with a pair of electrons actually at an allylic position. So in a way, it's similar to this anion, right? So lone pair at a carbon adjacent to a double bond. So it is allylic. Because of that, we say that that nitrogen is sp2 hybridized. So we will have p orbitals in all of the carbons and in the nitrogen. And the lone pair here is, this lone pair is delocalized. It is in a p orbital. So we need to count it, those electrons. So we're going to count 2, 4, and 6 because it is delocalized. So we say 6 pi electrons. This bond, this sigma bond, is formed by the overlap of an sp2 orbital from the nitrogen and the 1s of the hydrogen. So I'm going to do another drawing, say, showing another perspective, let's say. Let's imagine that now we have the ring is like that, so perpendicular to the board. So this is what is going on to you. So in that sense, we will have p orbitals, the ones that make the double bond, that are parallel to this. And the bond here is perpendicular to the system. So all of that is delocalized. So that's why we count that. The sigma bond here is made by the overlap of an sp2 orbital from the nitrogen and the 1s from the hydrogen. So we count those electrons. That's the bottom line to that. And as an example, let's do another example of that would be, say, I'm going to draw now pyridine. Pyridine is another heterocyclic molecule. So heterocycles will have a heteroatom, meaning another atom in the cyclic that is not a carbon. So it could be nitrogen, oxygen, sulfur. So that's another heterocyclic compound. In pyridine has the following structure. So do we count those electrons or not? So here, now we notice that all of the atoms here are sp2 hybridized. However, Let's do another drawing similar to that. Drawing in the plane perpendicular to the board like that. That's why I'm using wedges. You will have p orbitals, p unhybridized orbitals. So everything is sp2, and these are the p unhybridized. And hydrogen also is sp2. Is using that, you see that in the double bond, so you have this electron delocalization. And the lone pair here is now, lone pair is localized. So it's not part of the pi system, so you don't count it. When you are determining whether or not this is aromatic, you're gonna count the electrons only that are delocalized, part of that system. So you will count 2, 4, and 6. So this compound is aromatic, so you don't count those because they're localized. They are at an sp2 orbital that is perpendicular. It is in this. So where all the p orbitals are. Notice that these overlap nicely, and this is perpendicular. So no delocalization. You don't count those. So you count only those 3. That is important. So learning, distinguishing what electrons are localized and what electrons are delocalized, so that are they part of the pi system, delocalized, part of the conjugation or not. That's what we need to pay attention to when we are solving this type of problems.